Chances are you've got a pair of blue jeans somewhere in your closet. But have you ever really stopped to think about the incredible chemistry that gives them that classic, long-lasting color? It's a story that's way more about science than you might think.
I mean, really, think about it. Why does that deep indigo blue stick around, wash after wash, when so many other colors just fade away? Well, that's not by accident, that's by design. And it's the result of some very clever and kind of paradoxical science.
Yeah, the secret to that color staying put is a special kind of dye. But here's the twist. This dye has a massive problem, a fundamental flaw that, on the surface, should make it completely useless for coloring clothes.
So here's the deal. The dye used for denim, indigo, is totally insoluble in water. It's basically just a fine, colorful dust. And if you can't dissolve a dye in water, you can't get it to soak into the fibers of a cloth. It's literally like trying to stain a t-shirt with colored sand. It's just not going to work. So, how on earth do they do it?
And that right there is the huge paradox of this undyeable dye. The very thing that makes the color so tough and permanent, the fact that it won't dissolve, is exactly what makes it so hard to get onto the fabric in the first place. Okay, so this whole category of dyes is called vat dyes, and that name is super literal. It comes from the big wooden vats they used to prepare them in. Their number one defining feature, as we said, is that they don't dissolve in water. This is what gives them that amazing wash fastness, a 4 or 5 out of 5, which, trust me, is pretty much a perfect score in the world of textiles.
So that brings us right back to the million-dollar question, right? If the dye is just a powder that hates water, how in the world do you get it locked inside the actual cotton fibers of your jeans? You can't just rub it on and hope for the best.
The answer is a really clever chemical process called vatting. Honestly, the best way to think about it is like giving the dye a temporary disguise. A disguise that lets it dissolve in water, just for a little while so it can sneak into the fabric fibers.
And this is the trick right here. On the left, you've got that original insoluble indigo, but by adding what's called a reducing agent, don't worry about the name, all you need to know is that it changes the dye's chemical structure. You transform it into this leucoform on the right. And the big reveal, this new version of the molecule, well, it actually can dissolve in water. Problem solved. Temporarily.
Okay, so let's put these two side by side. On one hand, you've got the original indigo. It's that vibrant blue, but it can't get into the fabric. On the other hand, you've got this new leuco dye. It's usually a weird yellowish color. It dissolves in water, and it can soak right into the cloth. It's like a complete chemical alter ego. So this whole thing happens in 5 key stages. Let's walk through it. First, you mix the powder in water. Second, you do the vatting. That's the chemical reaction to make it soluble. Third, the fabric soaks up this new soluble dye. And then, stage 4, this is where the real magic happens, oxidation. You literally just expose the fabric to the air, and that reverses the whole process. The dye turns back into its insoluble blue form and gets trapped inside the fibers. And finally, you just give it a good wash to get rid of any loose bits on the surface. All right, so that's the chemistry in a nutshell. But how do you take that from a lab beaker to making, millions of pairs of jeans? Let's see how it works on an industrial scale. You guessed it. In these huge factories, this whole 5-step dance is completely automated. They run these massive rolls of fabric through all sorts of specialized machinery, with each machine handling a different part of the dyeing process.
So one really common way they do this is called the pad steam method. As you can see, the fabric just snakes its way through all these rollers. It gets a coat of dye, goes through a chemical bath, and then into a big steamer to lock in the color. It's basically a non-stop assembly line, but for color.
And there's another popular way to do it too, called the pad jig method. Here, instead of one long line, the fabric gets passed back and forth through the dye bath over and over to make sure it gets a really even soak. It's just a different way to get to the same result, that super permanent color.
Okay, so this process sounds pretty genius, right? It makes you wonder, why aren't all our clothes dyed this way? Well, as with anything, there are some serious trade-offs. So, the pros? The color fastness is incredible, top of the line, and you can get a ton of different shades. But the cons are pretty big. The whole process is really complicated and needs to be controlled perfectly. Like, if you don't do that final soaping step just right, you know how sometimes new jeans can leave blue marks on stuff? That's why. And all that complexity means, yep, it costs more money than other methods.
So let's just pull back for a second and appreciate this. We're talking about some seriously clever chemistry woven right into the very fabric of the clothes we wear every day. It's all about solving a big problem with an ingenious chemical disguise.
It really all boils down to this one elegant transformation. You start with the stubborn powder that hates water.
You trick it into becoming a liquid that loves water so it can soak deep into the fabric. And then, bam, you flip the switch, turn it back into that stubborn powder, and now it's trapped inside for good.
So really, the next time you pull on a pair of jeans, just think about the incredible journey that blue color went on. It's not just blue dye, it's the solution to a really tricky chemical puzzle, all to give you one of the most durable colors in your entire wardrobe.
And that just makes you wonder, right? What other bits of incredible science are hiding in plain sight in the everyday things all around us?